So you saw Viasat. We haven't. We should speak a little bit more about this payload because it's the primary payload, of course, is Escapade. You actually saw there in the middle of the video, we had a little side box there that showed the two twin satellites inside the fairing live, ready for their launch to space today. But on top of the payload adapter, kind of the base of where you saw the two satellites in there, is also this Viasat it's essentially a radio.
It's a demonstration.
It's a demonstration technology, radio technology for telemetry.
There it is.
Oh, well, there you go. There are the two satellites. What a beautiful, the two Escapade satellites. We got blue and gold in there. But I just want to talk about this because we talk about landing the rocket today. That is huge. But getting our customers to where they need to go is really, really important. So we're going to deploy those two satellites at about T+33 minutes. But then the second stage is going to continue in space, right? The two satellites go on their way. And that is when we're going to turn on the Viasat payload as well. So the Viasat payload is not going to deploy. It's going to stay on the rocket, and they're going to test their technology. And it's so, we feel so honored that we've got organizations like NASA.
Right.
We've got organizations like Viasat, one of the foremost satellite operators in the world, that are entrusting Blue Origin with their technology. And, yes, this is the second launch of our rocket, but we have shown that through the way that we do our engineering and our development and our testing program, that they said, okay, let's take a chance with you guys. And that means a lot to us. That is not lost on us. And so I want to thank, our customers, partners. All of our partners and customers that have flown with us and are going to fly with us. It really does mean a lot. It's not lost on us what our mission is.
Not at all. Little rideshare payload. The Viasat CPS technical demonstration is what we will be seeing. And you right there are seeing a live look from Jacqueline. And Ariane, it would look so much better, as you said.
God.
It's missing something.
It's missing. There's something
There's just something
off
that
on
could go
this
right
image.
in the middle.
Right.
It would look real good.
Can I tell? A lot of people don't know this. That landing pad is the same size as the landing pad for New Shepard.
It is.
Which,
that's right.
The rocket is 5 times taller. Just think you scale something up 5 times, and we're going to land. To be fair, that's all stacked together. But it's still 7 meters in diameter, and the first stage is massive in its own right. It's still like landing a building, but it's on the same circumference as New Shepard.
It is a moment that I know we're all kind of on the edge of our seats waiting for. I certainly am. We've been building up to this moment for months, and then technically for years, if we look at how much time it has taken from the start of this company. 25 years ago, we just had our 25th anniversary, and something really interesting, Ariane, 10 years to the month and almost to the day is when we landed the New Shepard booster.
Yes, it was, and I don't want to be misquoted. I think it was November 15th. It'd be off by a day or two.
That's all right. No one's holding you to it.
But it was of 2015.
Yeah.
When we landed New Shepard for the first time, and that was the first time any organization had ever landed a booster that had gone to space before. And I had the honor of being down there. The organization looked a little bit, Blue Origin looked a little different than it does today. We had a couple hundred employees. We're now over 10,000 employees.
Yeah.
We basically had, we had Kent and we had West Texas, and that's it. And there was a group of, I don't know, maybe like 15 of us, a dozen of us on this back porch. Of course, there was mission control, and it was the second time we had attempted this, similar to, there are a lot of parallels. Similar to New Glenn, we had a beautiful first launch, but if it were an expendable rocket, it had been a perfect first launch. We didn't land the booster the way we wanted to, and on the second launch, we launched it, and it came back, and Tabitha, this is like ingrained, like just burned in my memory, is this rocket came down, and we heard on this handheld radio, the engines, like, drag brakes deploy. Engine relay, and where people are just like losing it,
holding their breath,
and you see in the distance, because for New Shepard you're a couple miles away, and it kicked up all this dust, and then we heard touchdown, And there you go. See, you see our happy engineers? It was like that. We just lost our minds. And I am sure that today, when this rocket comes down and does the same thing, as we've scaled up, everything gets scaled up, all the energy, it will be over 10,000 employees losing their mind. Is that man wearing a kilt?
There's no judgment here. This is awesome.
I love
more
it.
kilts.
I love it. Hashtag more kilts.
But one thing is, you know, we have built this company for a lot of things, and another big piece of it is customer focus.
Yes.
I got the chance to talk to Dave Wimp about this yesterday. It's such an important part of everything we do, and it really ties into something else that we have, and that is our Mars Telecommunications Orbiter, or MTO. And let's kind of dive into this for a little bit. So current communications spacecraft at Mars, they're aging. They have new and robust capabilities out there that can kind of support not just our existing rovers and instruments doing groundbreaking work on the Martian surface, but also to lay the groundwork for more science and even more human missions. Well, the first human mission and all those beyond that.
Exactly. And our Mars Telecommunications Orbiter is based on existing blue ring vehicle, and it provides high rate communications, but also does much more in a single spacecraft.
Yeah, in addition to communications, our Blue Ring MTO could also fly exciting science payloads and technology demonstrations. For example, flying a synthetic aperture radar on Blue Ring MTO will help us find the ice on Mars, which will inform future landing sites for human missions. So take a look at our Mars Telecommunications Orbiter.
Tabitha, that concept is really cool. I also want to warn you, I am very biased. Because
Tell me why, Ariane. Why am I biased?
So about 6 months ago, I took my current role, but prior to that, I had the honor. Oh, hold on. Just a note. Well, we definitely have rain out there on the pad.
But this is Florida. If you don't like the weather, just wait 10 minutes.
Well, exactly. So but now you guys know why we were waiting for a little bit. We saw this coming, so we're just holding here and added a little bit more time to the clock, and that's why we're still holding about 24 minutes and 50 seconds to go until launch. We're going to wait for this to pass. But as I was mentioning, prior to taking this current role, I had the honor of being deputy in charge of our in-space systems business unit that is building Blue Ring, and Blue Ring has this ability to take up to 13 payloads and then deploy them, but then also act as the comms relay, also do edge computing in space. So basically, you know, in a very simplified way of talking about it, it's kind of like a mission in a box. You can take that whole constellation, send it to Mars, deploy the satellites, and then use the Blue Ring itself, which did its first job as transporting, to then be the communications relay back to Earth. And the more power you have in that comms capability, the faster you're going to get the data and the communications. Right now, one of the biggest issues is that Mars is so far away. So, like, there's this huge delay. The better the comms you can have, the better we're setting up, as you were mentioning before, you know, future, not just the science that needs to happen to prep us for our future missions to Mars for, let's say, robotic landers and things like that, but also for people to go to Mars one day. So we're really excited about the prospect of this mission and what we can do, again, for our customer here at NASA as they think about future exploration missions.
Yeah, it's so exciting to hear just about everything that is happening. Again, you are watching the webcast for NG2. We're at L-minus 23 minutes and about 20 seconds. Let's toss it back over to New Glenn on the pad. That booster, so appropriately named, Never Tell Me the Odds, looking nice and cool. Well, Ariane, right now you and I, we're sitting here at the desk. We were looking at this beautiful image of New Glenn on the pad. But yesterday, you and I actually got to go out to the pad. We had some time to look at NG2 in all glory. And so I want to talk about how cool it was for us to go and see this engineering marvel.
Let's check it out.
Okay, so walk me through kind of the different components of this rocket.
Okay, so on the most very basic level, we've got GS1, and then stacked on top of it, GS2. It's basically like stacking a rocket on top of a rocket, right? So let's maybe start with the GS1 because it's doing a lot of the work today, right? And we want to land this booster as well. At the top, we call the forward section. You'll see kind of a gold section up there at the top where the 4 fins are.
Right.
Those fins, they move back and forth, right? So they help with directional capability on the rocket. The whole main section of it, though, in the middle, is basically a big fuel tank. And then you get to the aft, the bottom section there, that has the landing gear you see in each of the doors, but it also has the 7 BE4 engines that are in the base.
Right.
At the top, then, so that's basically GS1. At the top, basically from the white portion above the gold and beyond, tucked in there are the 2 BE3U engines. The part with the feather, again, that's all basically tank, liquid oxygen, liquid hydrogen for the propellants. I forgot to mention liquid oxygen and liquefied natural gas, the propellants for the first stage, so they're different propellants. And then kind of that nice, smooth top, that is the fairing. There are 2 halves of the fairing, and those will deploy off, those will fall apart once the second stage is up in space.
Right.
And inside the fairing is where the Escapade, the 2 payloads, the 2 satellites of the Escapade mission are currently...
twins.
They're twins. They're on what's called an ESPA ring. And so it's a ring that mates to the top of the rocket. And then on that ESPA ring, we put the 2 satellites. So once they're up there in orbit at about 33 minutes, first the blue will deploy. We wait 30 seconds. Pretty obvious. We don't want them to run into each other, right? And then second, the gold deploys. So that's what happens with the second stage once it's out of space. But keep in mind, first stage,
making its way home.
It's making its way home, right? So the engines have done half of the work on its way up. We flip it around. We start a burn that slows the rocket. Right. We then use the strakes, or they're basically our wings at the base of the rocket. It helps with what we call cross range. So we basically can effectively fly the rocket, and then it lands on the Jacqueline platform just in the last couple minutes or less even. We have 3 of the 7 engines that relight, and then finally just the final engine that lights. You don't need all of the power, all the engines, because you're landing what is effectively an empty fuel tank.
And something the size of a skyscraper.
Something that's the size of a skyscraper. So you do need power, obviously, but not as much, obviously, as when it starts. And then it should come for a nice soft landing on the Jacqueline. And if we do that,
it'll be pretty epic.
It'll be history. It'll be epic, and it opens a new chapter for Blue Origin.
So appropriately named. Never tell me the odds.
Don't tell me those odds.
And Ariane, it was really, I don't know, almost like an out-of-body experience to be standing next to New Glenn. I have been to New Shepard launches. This is my first New Glenn launch. And to see New Glenn upright, and to be in the presence of something the size of a skyscraper, and to learn, as you mentioned, it's essentially a rocket stacked on top of a rocket, right? And it has so much history. It's just like, I don't know, Space Coast is such a special place. This launch is so special. This rocket is so special. So
yeah, I had a chance to chat with some of our customers and our VIPs that also got a chance to check out the rocket. A lot of them, of course, have been in the industry a long time, and they got out there for a photo op yesterday, and they said, "This rocket just looks beautiful." Yeah. And there is something to be said, actually, for you can look at a piece of engineering. I know it's very simplistic, but you can look at a piece of engineering and be like, aha, that looks right. That looks right. It feels right. You add too many bells and whistles and you're like, it's not. This rocket is a marvel of engineering. It flew so well on its first go. I cannot wait to see how it performs on its second go. And as we said, we're cautiously optimistic. We've made some changes to the first stage after our first launch, where we didn't recover the booster to be able to land this time, and we feel good. We feel good. I don't want to jinx anything, but man, I feel good.
Knocking. I knock on
knocking all over the place. Yeah.
But you're right. I've been talking to employees, for months leading up to this moment, and employees do feel good. Engineers feel good, and this launch, it feels different. It feels good. And I think everyone is just, on the edge of their seat at this precipice, right? We're ready to land the booster.
It would feel a lot better if these clouds got out of the way, if this weather got out of the way.
We are in a weather hold. So here's what's going on. If you are tuning in right now, you're watching the webcast for NG2. You might notice on your screen that we are in a hold. We're doing that to allow for a little more time for that weather to clear. We're going to let you know and keep you guys posted on the new T-clock as soon as we get information on that. So right now, let's toss it back over to New Glenn on the pad as we wait for some of this weather to just kind of move on out.
Roll on by.
Let's get out of here. All right, friends, you are watching the webcast of NG2. We are currently in a hold at about L-20 minutes. But in the meantime, here's something we love to do here. We love our jobs here, and we also love inspiring others. We want to inspire a few more of you also at home with our nonprofit Club for the Future. Club has the mission to inspire and mobilize future generations to pursue careers in STEAM. That's science, technology, engineering, arts, and math, all for the benefit of Earth. I am the A in STEAM. Yeah, which is the arts part.
Which is super, super important. The ability to communicate about it, right? Like, it's so, so important, the A component of STEAM. But as part of the Club for the Future program, one of the cool opportunities that we give is we allow students to send postcards to space and back via New Shepard, and we also provide online STEAM-based lesson plans that are free for students and teachers to use. And then so that everybody can get a piece of the action.
That's right.
Even easier is that we have these digital postcard, this drawing tool that you can go online, and anybody can send that art to space. So for more information, if that sounds cool to you, just go to clubforfuture.org.
That's right. That's clubforfuture.org. Ariane, where do you fall in the STEAM spectrum? You're a bit of everything, I feel like.
I've always kind of been like...
You're like, I'm science and technology and a bit of engineering and math.
Yeah, but I kind of like it all.
Yeah. And arts today and anytime we get the honor of having you with us.
Let's be very clear. I'm not the one that's going to be designing that insane trajectory that Advanced Space did for Escapade today.
Right.
So, like, props to you guys. But I love every part of space and all that goes into it, and clearly the A part of it is also incredibly important.
It's neat to have such a cool team of all of the great letters that work together. And Jeff himself has said that it is this generation's job to build a road to space so that future generations can unleash their creativity. Check it out.
When I was in high school, I was working to build a rocket for a target altitude competition.
My mom took me to a observatory opening, and I got to see the rings of Saturn through a telescope.
Growing up, I was just not very good at doing school. I wasn't really good at doing homework.
There was a teacher at my school, Mr. Cullen, and we spent hours together after school. I would be building a rocket in the back of his class, and that was incredible for me.
I had a chemistry teacher who also taught astronomy, sparked that interest in me. She went outside the lines of what I believed a science person should be.
It helped jumpstart a passion where I am now a propulsion engineer launching rockets.
If a teacher like that could help a student like me and pull me to this career, it just makes me think, you know, what can I do to help inspire the next generation?
And that was life-changing for me.
And that's what Club for the Future is really all about.
Science, technology, engineering, arts, and math, and all for the benefit of Earth.
We're here to create meaningful experiences that spark curiosity and ignite passion.
We're teaming up with educators to make learning an adventure by creating space-based lessons for K-12 students.
If we want to see millions of people living and working in space, space should look like all the populations of Earth.
Our goal is to make learning about space more accessible for all. So we've joined with others to reach underrepresented students and underserved communities.
But it's not just about what happens in your classroom. As Blue Origin's Club ambassadors, we're here to share our expertise and inspire students through speaking opportunities, events, and mentorship.
Also, with our Postcards to Space program, kids can connect with the vastness of space and the future of our planet.
Draw your vision of the future or write any message you want on a postcard and we'll launch it to space and back on a New Shepard rocket.
Your postcard will be stamped, flown to space, and returned to you as a unique keepsake.
So let's go. Let's dream big, reach high, and build a future where the possibilities, they're as endless as the stars.
Love Club for the Future, and you saw those really excited employees out there.
Yeah.
There they are, losing it. That's right. Team Blue. Looks like, I think this is our team in Huntsville. There's our team in Kent. Coming in on a Sunday to cheer on their rocket.
Woo!
You see,
I want to cheer with them. I want to be there.
If we land this rocket today, they're gonna
go nuts.
This is cheering.
We may not be able to show it.
There's a team out here in Florida. You see, they're on top of the garage just right next to us. They've got the best view for this launch. There's our team. They are ready to rock and roll. I love it. I absolutely love it. The team at Blue.
There they go.
You're on TV.
We're waiting too. We understand. We're waiting on that weather hold to lift. Everyone's excited, but the time is coming.
Where our team is they're still working on the situation with the weather and assessing the weather conditions out there, but otherwise speaking, the team and the rocket are ready to go. It looks beautiful.
Looks beautiful. And I think what you were saying is, employees are so excited, and they're also very involved in community, and they're involved in schools, and Club for the Future gives us that opportunity.
Yeah, and it's not an accident in the sense that, our vision is millions of people living and working in space for the benefit of Earth.
That's right.
Right?
For all of Earth.
For all of Earth. And we need to 3 steps to that. We got to reduce the cost of accessing space.
Number 1.
We need to figure out then how to go to space and take advantage of the resources that are out there to make life on Earth better. And the third key part of that is inspiring the next generation. This is not a project that is done in 6 months. This is not building an app, right? Like this is
forever.
Decadal, generational type of work. And if we don't have a strong next generation to pass the baton to, that is super excited and is trained and is motivated to do so, then what are we doing?
Knowledge is power.
It fades if you don't pass that baton on. And so that's why at Blue we've made it a core part of what we do. And I don't use like the big, we Blue Origin, but literally as individuals, there are so many of us that we call club ambassadors. That
I'm one of them.
I'm also
one of them.
Go and speak about space on behalf of Blue, but arguably on behalf of the industry, because that is such a critical component of what we do. So props to the actual group within Blue Origin, our Club for the Future team.
Heather and Lucas and Chris, and they love to reach out, and we love to help them out anytime. Recently, I even had the opportunity to speak to a group of students in India.
Oh, I love it.
I had just gone to India last year, and the fact I was able then to turn around and talk to them and relate not only my travels to India to what we're doing in the space industry here and what we're doing at Blue, I mean, it really brings a tear to my eye because it's so cool to be able to make those connections. So you can tell we love Club for the Future. We love inspiring the next generation, and we love inspiring you too at home. But if you're just joining us, this is the webcast for NG2. We've got a live look on the right side of your screen of Jacqueline. Would look a lot better once that booster goes up, and we maybe set it down right where that feather is. It looks like a good spot right there. And then, of course, on the left-hand side, you have New Glenn on the pad ready to go. But let's talk about the flight profile overall. While we're in this hold, we're in a weather hold right now, we made a really cool video that dives a little bit deeper on the entire flight profile of New Glenn. So check it out.
New Glenn lifts off from Launch Complex 36 on Cape Canaveral. 7 BE-4 engines will ignite and propel the rocket upward with over 3.8 million pounds of thrust, or roughly 17,000 kilonewtons. The vehicle will quickly reach supersonic speeds as it climbs through the atmosphere. As the rocket ascends, it will encounter maximum aerodynamic pressure, known as max Q, at around 40,000 feet, or 12 kilometers. This is the point at which the stress on the vehicle is at its highest. Around 3 minutes into the flight, the vehicle will turn off its engines, marking the end of the boost phase. Shortly after, the reusable first stage will separate and begin its journey back to Earth. 2 BE-3U engines on the second stage will ignite and propel it onward into orbit with the payload. The reusable booster reorients in the vacuum of space using its reaction control system. At 220,000 feet, or 67 kilometers, it executes an exo-atmospheric deceleration burn using its Center 3 engines. These engines gimbal for maximum control of the booster. This burn slows the vehicle down before re-entering the atmosphere. As it descends, the booster's strakes and fins work together to slow it down and guide it autonomously back to Earth, landing on a vessel at sea. At around 9,000 feet, or just under 3,000 meters, the first stage begins its final landing burn. The 3 middle engines will light for 20 seconds, slowing the vehicle in preparation for the final descent. The 2 outer engines will turn off, and the center engine will execute the final controlled maneuver onto the landing platform. The vessel will return to Cape Canaveral to prepare for its next mission. Meanwhile, in space, the second stage will continue to power the payload towards its final orbit. At around 400,000 feet, or 120 kilometers, the payload fairings will jettison. New Glenn will deliver an unprecedented range of payloads. Large satellites, dual payloads, orbital vehicles, large constellation dispensers, even moon landers destined to establish permanent human presence on the moon. Once it arrives at its insertion location, the payload will separate from New Glenn's second stage. This is New Glenn. This is how we will build a road to space.
I get chills every time I see that feather come on screen. It's such a great piece pulled together to really explain what's going to be happening with NG2. So there you go. You have a live look, though, of New Glenn on the pad. Now you understand the entire flight profile. But while we're in this hold and we're working out weather, let's go ahead and send it back over to the rocket and just sit with NG2. All right, friends, you are watching the webcast for NG2. We are currently in a hold at about the L-20-minute mark. And I got an update for you guys. We're waiting on weather. You might be looking at that and be like, oh, weather looks pretty good, Tab. But then and I'd be like, you're right. It's looking a lot better, huh? Well, we're also chasing some boats out of the way.
Boats!
There are some boats that are essentially being told, hey, you're in our flight path. You got to get out of here. They should have known that to begin with. But that's just one of the other things that you deal with when you deal with rocket launches.
I'm gonna try to see the silver lining in this, or I'm gonna try to be the ever optimist that I am. Last time we had this launch, we also had an errant boat in our in our flight path, and we had a pretty spectacular launch. And we put our payload, got to orbit, we filled our objective. So I'm going to call this a good luck omen.
A good luck. You know, speaking of good luck omens, yesterday, me, you, and our very own Eddie Safert, we were headed out to the launch pad, and we saw a tortoise crossing the road. And if you didn't know, tortoises are a part of our coat of arms, and we find them as a sign of good luck. So, Eddie, you are out there. You are with employees. You're at the best spot to see the rocket launch. But let's talk about something serious for a second. Let's talk about how hard it is to land the booster. For those of you who don't know, you probably do know if you're watching this webcast, on our first attempt, we weren't able to land the booster, but we were able to get our payload into orbit. Today, our big objective, aside from getting our payload into orbit, which is Escapade, is we want to land our booster. No, never tell me the odds, and I like the name of that booster, so I want to keep it. So, Eddie, how hard is that?
Well, so first off, thank you for your patience. The weather here is looking a little better. The boat this time, definitely safety is our highest priority. And the tortoise, for me, a sign of good luck. I mean, I think it's just a trifecta of signs that we're ready to not just launch Escapade to space successfully, but to land this booster. So we learned a lot. Nothing substitutes flight data. So the GS-1 booster, after it separates from the GS-2 upper stage, it does a 180-degree flip maneuver so that the aft section is facing backwards, or basically back down to Earth, but in the flight path. And so that 180-degree maneuver is conducted by our reaction control system. They're peroxide monothrusters. We call them the severe weather agility thrusters. And those worked perfectly last time. We did the maneuver. And then the BE-4 engine goes for reignition. So the 3 center engines reignite what we call the exo-atmospheric re-entry burn, and its entire purpose is to slow down the GS-1 as it re-enters the atmosphere so that its superior aerodynamic performance, those long strakes, those forward fins, can guide the GS-1 booster over the Jacqueline.
Yeah, Eddie, thank you for such a good explanation for our viewers at home, because it took a little bit for me to understand, too, exactly. I'm like, why is it so difficult? And it's like, Tabitha,
it's hard.
It's pretty difficult. And I'm like, yeah, it's like when you watch the Olympics and you watch someone run fast, you're like, oh, I can do that. It's like, no, you can't. It's actually quite difficult. So, thank you, Eddie, for that great explanation. Again, we are currently in a hold. You are watching NG2, our webcast here. We are at about L-20 minutes. We're going to toss it right back over to the rocket. New Glenn is on the pad. It is feeling cool. It is looking cool. And it is literally, Ariane, very cool right now. All right, friends, you are watching the webcast for NG2 right now. You can see New Glenn out there on the pad. But an important part of what's happening today with New Glenn is we are sending Escapade to Mars. And I got the extreme privilege, the honor, if you will, to talk to the principal investigator of Escapade, Dr. Rob Lillis. Check it out. Rob, for someone who doesn't know, what does the principal investigator of Escapade do?
So the principal investigator is entrusted by NASA to execute the entire project. So it's kind of like the buck stops with me. I have a team of excellent people around me, but I'm responsible for the production of the data, the definition of the science requirements, the execution, the technical aspects of the mission. I think it's a great model for how NASA sort of entrusts the completion, the execution of a mission to a partner like UC Berkeley, where I'm based.
And Escapade is a really special project. We are so excited to be taking it up today on NG2. Tell me a little bit about what Escapade does.
So Escapade is a twin spacecraft mission going to Mars, orbiting Mars to sample the ways in which Mars and its upper atmosphere respond to changes in space weather. By space weather, I mean the million-mile-per-hour stream of charged particles that the sun is at all times throwing at. Sometimes that stream gets gusty, and the gustiness, essentially, of it is what we call space weather. And there's all sorts of ways that can happen. The magnetic field can get stronger, the speed can get higher, the density can get higher, and all those things have an effect on the Martian atmosphere. And over time, it can strip away the particles in the upper atmosphere. And we know that this has been an important process by which Mars's climate has changed over Martian history. Early in Mars history, up to about 2 billion years ago, Mars was at least occasionally warm and wet. It had a thick atmosphere. It was habitable. We don't know whether life actually existed, but it was habitable there. But then in the last 2 billion years, it's lost most of its atmosphere. And we think that the stripping of the atmosphere by the solar wind is a big reason why that happened. And Escapade is going to be sampling and investigating these processes with a stereo perspective with 2 spacecraft. And that's really important, because up until now, with one single spacecraft, we've only been able to measure either the solar wind itself or the effect of the solar wind closer to the planet. We've either had the cause or the effect, but separately. With Escapade, we can have 2 spacecraft simultaneously cause and effect at the same time. And so that's the breakthrough that Escapade is going to provide us in understanding the processes by which the atmosphere is stripped away.
And once we understand that, I mean, how does that affect us here back on Earth or future Mars missions?
Right. So it's important for a couple of reasons. One, I think we're just curious as to how planets evolve in general. Like planets, they change their atmospheric composition. They're more volcanically active, and that can affect the atmosphere too. And so this is an important piece, isn't the only piece, of course, but it's an important piece of the puzzle of Mars climate evolution. And that's interesting just because we love to explore as humans. But it's also important because space weather can have a practical effect on robotic spacecraft that we send to Mars future, and also humans when they explore Mars. This is important for a couple of different reasons. One, a big space weather event, what's often called an interplanetary shock or a coronal mass ejection, when the sun belches out a couple billion tons of hot plasma, often at high speed, high density. As that shock expands through the solar system, it accelerates particles to really high energies. High enough energies that they can go right through a spacesuit and cause astronaut health problems.
Right.
And so the radiation on the surface of Mars, when you get a big enough coronal mass ejection, you can get 100 days worth of radiation in one day. This happened last year. Wow. This happened last year, June 6th, 2024. The usual background level radiation was increased by a factor of 100 for that day when that happened. And so if you're an astronaut on the surface of Mars, you don't want to be out away from your radiation shelter when that happens. And so Escapade's measurements are going to enable us to better forecast those radiation hazards. There's another reason, too, Escapade's important, because we're also going to be studying the ionosphere. So this is a layer of gas in the upper atmosphere that's ionized. And that's important because that layer, it distorts radio signals as they pass through it. And understanding the variability and the structure of that ionosphere will help us to correct for those distortions.
For communication.
Communication, but also for navigation, because there's going to want to be GPS on Mars eventually. And understanding how the ionosphere distorts the GPS signals will enable astronauts to know better where they are. All these things are taken into account on Earth. It's all behind the scenes. So your phone doesn't have to show you how they're correcting for it, but that's all behind the scenes on Earth. We want to be able to do that same
error correction on Mars, and Escapade will help us understand the ionosphere.
It's really cool to know that we're thinking about these future problems now.
Yeah.
And speaking of things that are happening in the future, I mean, Escapade is not going to be making it actually to Mars. The spacecrafts aren't going to be there for at least 2027.
That's right. That's right indeed, yeah.
So what happens once Escapade deploys? Kind of tell me more about the trajectory.
Okay, well, so after it deploys, first of all, there's a few important checkouts we have to do. The first thing is we got to deploy the solar panels, and we got to get it to speak to us. And so actually, the viewers will be interested to know that we may not hear from the spacecraft for up to 3 hours after launch. And that is by design.
Okay.
Because we have 2 antennas, one on either side of the spacecraft, and they only work one at a time. And we don't know which one necessarily is going to be pointed towards Earth initially. So if the one that turns on first happens to be pointed away from Earth, we got to wait 2 hours until it decides, oh, I'm not hearing from Earth, and it switches over to the other one. So no one should panic if we don't hear from it within that first hour. But once we know that we have signal, we're hearing from it, and we know the solar panels are deployed and they're facing the sun, so that's called power positive, so it's a safe and a stable mode, then we can relax, and then we can start focusing on the longer term aspects of the mission. And you mentioned trajectory. So yes, we are taking quite an unusual path to Mars. We are going to spend about a year in a very large Earth orbit, fairly gravitationally bound to the Earth. We're calling this the loitering phase. It's in the shape of a kidney bean. It kind of goes like this. And next November 2026, we're going to come back to Earth after going more than 2 million miles away. We're going to come back to only 600 kilometers above the surface. We're going to use Earth's gravity and burn our engines at that point, taking advantage of Earth's gravity to slingshot ourselves toward Mars. Because early November next year is when the interplanetary window opens for a transit from Earth to Mars. So all Mars missions before us have had to wait until this narrow 3 or 4 week window every 25 months. We're launching halfway between these two windows, so we're just going to kind of hang out in near Earth space until it's time to go to Mars. And this has never been done before. And this is really, really exciting because this actually opens up the possibility in the future. If humans want to actually settle Mars, we're going to have to send hundreds, maybe even thousands of ships to Mars within that 2 or 3 or 4 week window. And there aren't enough launch pads on Earth to reliably do that just within that window. So we could launch them over the course of a whole year, maybe, and we could like sort of queue them up, so that they're kind of lined up so they can go when that window opens. And so this is hopefully going to pioneer a way to essentially enable interplanetary settlement in the distant future. Who knows?
And once the mission actually starts, how long is the mission going to be going on?
So, so I mentioned November 2026. That's when we start our interplanetary cruise. We spend 10 months in that cruise to Mars, doing little trajectory correction maneuvers all the time, little tiny engine burns to like just, barely tweak our path so that we can intercept Mars in early September 2027. And that's when we got to do another big engine burn to be captured by Mars's gravity. And that's when we will be in Mars orbit. Then we spend another 7-8 months-ish adjusting the orbits.
Wow.
So first of all, lowering the orbits and adjusting the orbits. And this is important because Escapade is doing another thing that's never been done before, which is the first ever formation flying around another planet, other than the Earth or
lot of firsts on this
the Moon. It's kind of like pearls on a string. Both spacecraft have to get into the same orbit. And it takes a while to adjust both orbits to make that happen. And also in the middle of that, there's what we call solar conjunction, where the sun gets in the way between Earth and Mars, and we can't talk to it for a whole month. So we kind of just have to chill out, go into safe mode, and just wait. And so this is the reason why it's going to take us an additional 7 months after we get to Mars before we can start the science mission in spring 2028. And then we have an 11-month science mission, and that's also...
So this is going to take us all the way into 2029.
Yes, exactly, yeah. It's, I think, May 2029 is the nominal end of the science mission. And I mentioned the 2 spacecraft are going to be the pearls on a string. We do that for the first 6 months. And that's important because we want to know how the upper atmosphere of Mars is changing minute to minute. So in the past, with only single orbiter missions, we've had to wait 4 or 5 hours to see how things have changed. And by that point, the planet's turned a quarter rotation, things are different. We don't know how anything changes on short timescales at all on Mars. Escapade is going to pass through the same part of the upper atmosphere twice in a quick succession, so 2 minutes to 30 minutes apart, to see how it changes on those short time scales. Once we're done with that, then we raise one orbit, we lower the other orbit, and then the two orbits are different, and they start precessing. This is a word for the orbital planes moving with respect to each other.
Okay.
And this allows the two spacecraft to get much further apart from each other to make those simultaneous cause and effect measurements that I mentioned earlier, to understand the real-time response of the upper atmosphere to the space weather events.
And so, with all that, understanding how Escapade works and knowing that this mission is going into 2029, how do you feel today?
I feel excited. I feel a little anxious, as everyone does on launch day, but I am super, super excited. I'm proud of everyone who worked on Escapade, at Blue Origin, at Rocket Lab, at Berkeley, at Embry-Riddle, all of our partners. Advanced Space LLC, they were the ones who did most of the work to design this innovative path to Mars as well. And so I'm just so proud of the whole team. Probably thousands of people have worked on bits of it up to this point. And we're so excited to reach this day, the culmination of so much effort and the beginning of the next chapter.
And the last question I have for you is something I ask everyone, and that is there anything else you want to add or say or mention that I didn't ask about that you think is important to this interview?
So Escapade is a very low-cost mission. Escapade is only about 1/10 of the typical cost of a NASA planetary mission. This is a radical experiment by NASA in seeing whether they can accept slightly higher risk and less oversight in exchange for a much lower cost. And the idea being that overall you get way more science per dollar if you do this. And
so bang for your buck.
Bang for your buck, science for your dollar, and it's because we are embracing, as I said, a lighter sort of a touch by NASA. We're using more commercial off-the-shelf parts. There are fewer reviews. There are fewer sort of requirements. NASA's